Good evening. This is video number 403, and in this video lecture I am going to show how to compute and interpret the analysis of variance results in STATA. So in video number 401 I have used SPSS for computation and interpretation of ANOVA. In this particular video I am doing the same analysis in STATA. So let me start with an example. This is my SPSS. This is data. This is my SPSS file, which I used in video number 401. And here in this figure, my response variable is exam score, and study technique is my independent variable, which is a categorical variable having three categories. There are three studying techniques: technique 1, technique 2, and technique 3. So I am going to see whether there is any difference between the mean exam score between the various studying techniques. So how to do that? I'll open my STATA data, the file that I have saved in STATA, and then I'll show you how to do that. So here is my data. This is my data. Let me describe this. And there are two variables. One is variable 1 and the other one is variable 2. So my variable 1 is studying technique and my variable 2 is exam score. And I want to use one-way analysis for multiple comparison. So in linear models and related, I'll go to ANOVA and MANOVA, and then I'll click on one-way ANOVA. After this, I'll write my response variable. My response variable is exam score, which is variable 2, and my factor variable is the study technique, which is variable 1. After this, I would like to do multiple comparison tests. So Bonferroni, I will use Bonferroni test, and I'll also click on produce summary table. So after that, I'll submit my results, and here is my output. So the command is one way. This is variable 2, that is the exam score, and this is the factor variable, which is a study technique, and after comma there is a Bonferroni and tabulate. So when I give this command, first I get summary of exam score. Here is the mean, here is the standard deviation, and these are the frequencies. So the total number of students is 15, 5 in each category. This is in technique 1, this is technique 2, and this is technique 3. And this is the mean exam score for those students who use technique 1, and this is the mean score in exam for those students who used technique 2, and this one is the exam score for those students using technique 3, and this is the overall average, and this is the overall standard deviation, and these are the other standard deviations for the students using various techniques. Here is the analysis of variance. This is between groups, and this is between within groups, and this is the overall. And here is the F stat, and its p value is less than 0.05. So this is significant. So it means that there will be a difference between means of the various techniques. At least one of the mean exam score will be different from the other two. And then I also use this Bartlett test for equal variance, and its chi-square value is 2.0840, and its p value is 0.353. Now here the null hypothesis is that variances of the different groups are homogeneous. That is, there is no difference between the means of the three groups of students using different techniques. Since this value is greater than 0.05, so we fail to reject, and we accept that the variances of the exam score for the three different techniques are equal. That is, they are homogeneous, so there is no difference. in variance across students in using different study techniques. My final variable is this, and this is the Bonferroni test for comparison of exam score by study technique. Now, if you look at this, this shows row mean minus column mean. So this value mean the mean value, the mean score of exam for the students who used technique 2 minus the mean score of the students who used technique 1, and that is equal to 12.4, and its p value is significant. So it means that the difference between students using technique 2 and students using technique 1 is statistically significant. However, the difference between the mean score of students using technique 3 and those using technique 1 is equal to 7, and its p value is equal to 0.288. So this is not significant. So it means that there is no difference between the mean score of students using technique 3 and technique 1. Similarly, there is also no significant difference between the mean exam score of students using technique 3 and students using technique 2. So as I mentioned earlier, on the basis of this p value, at least the mean difference between group 2 and group 1 is statistically significant. However, the mean difference between group 3 and 1 and the mean difference between group 3 and 2 is not statistically significant. So ladies and gentlemen, this is exactly the same that I did in video number 401, in which I used SPSS. So the results are exactly the same, however the methods are different. So if you like the video, kindly share it with your friends, with your students, and subscribe to the video and like it, and do not forget to click on bell icon. And thanks for watching. Kindly share this with your friends. See you in another video.